In this video, we're going to look at how we can solve chemical calculation questions that usually follows titration experiments. First, let us review some important terms associated with titration. Firstly, the solution that we place inside the burette is known as the titrant. The drop of titrant that changes the color of the indicator at that point of the titration is known as the end point. At the end point, you have added just enough acid to react away your alkali, or you have added just enough alkali to react away your acid. Now, the volume of your titrant used is known as the titer value. So, the whole objective of performing a titration is to obtain your titer value. From the titer value, we can then go on to perform chemical calculations to solve certain problems. To solve chemical calculation questions involving titration, it almost always requires the 3C approach that we have learned in chemical calculations. The first C, which is to convert to moles. Now, in this case, we are dealing with solutions, be it acid, alkali, oxidizing, or reducing agents. They are all solutions. So to find number of moles of solutions, we need to use this particular formula. Number of moles equals to concentration times volume, or this particular equation triangle. Now, when using this equation, you need to be very, very careful because concentration is in moles per dm cube and the volume is in centimeter cube. So we need to first convert the volume to dm cube. So in almost every titration, the very first chemical calculation is to find number of moles, as we will see in some examples later. The next part, you're required to compare mole ratio. So there will be some equations given in the question, and by comparing mole ratios, you can find number of moles of the other reagent. Okay, and then the last part, we need to convert the number of moles to something else. Usually the last part of the chemical calculations is the hardest to score. That's where students tend to make mistakes. Another important concept that we need to revise for chemical calculations involving solutions is how to convert concentration from grams per dm cube to moles per dm cube and vice versa. Now the trick is this, is to ignore the dm cube. So if we are converting grams to mole, if you are given mass, how do you find number of moles? Is to divide by molar mass. And the reverse is also true. How do we convert from moles to mass? Is to multiply by molar mass. Now, to solve the last parts of chemical calculation questions, you need to very importantly note the story behind the titration. Now, where do we find the story behind the titration? We find it in the introduction paragraph, or the very important piece of information is usually found here. Okay, so somewhere in the introduction, they will tell you what is solution P and what is solution Q, or how were solutions P and Q prepared in this titration. So this piece of information is going to be very important for you to solve the last part of the chemical calculation. Now we'll look at the first example, which is your 2021 practical paper. There was a titration between sulfamic acid and sodium hydroxide. So once again, the very important part of the story is found in how Q was actually prepared over here. Now, if we look at the story behind this titration, it's talking about some cleaning product that contains sulfamic acid. And this cleaning product that contains sulfamic acid was then diluted to produce solution Q. And in the titration, we actually made use of this solution Q. Now, there are two important parts to this story that you need to take note. Number one, there is a dilution procedure. So 100 centimeter cube of the cleaning product was diluted to 1 dm cube, which is equivalent to 1000 centimeter cube of your solution. And then the solution that we get is solution Q, and from solution Q we had pipetted 25 centimeter cube of solution Q out to titrate with sodium hydroxide. So this is the story behind the titration. Now there's one very important concept that usually is taught in A levels involving dilution, but it's good to know it now, that in dilution the number of moles of your substance do not change. So in this case, when we dilute your sulfamic acid from 100 centimeter cube to 1 dm cube, the number of moles of acid do not change. So with that in mind, the number of moles of acid before dilution is actually equals to number of moles of acid after dilution. And once again, when we look at solutions, number of moles is equivalent to concentration times volume. So the concentration and volume times volume before dilution is equals to concentration and volume times volume after the titration. Now how do we make use of this equation? Is something like that. Now imagine that we have found out that the concentration after dilution is actually 0.1 moles per dm cube. Okay, so how do we find the concentration before dilution? Is this, that the concentration before dilution times the volume. So we had used 100 centimeter cube of the cleaning product is equals to the concentration times the volume after the dilution, which is 1000 centimeter cube. Okay, in this case, actually there's no need for you to convert to dm cube. You can leave both as centimeter cube, and from there you can see that the concentration before dilution is actually 10 times or 1 mole per dm cube. Now the second very important part that we need to take note of this story is that we have actually pipetted 25 centimeter cube of solution Q for the titration. What it means is, from your chemical calculations, whatever number of moles of acid that we have obtained using the first and second C is only for the number of moles of acid in 25 centimeter cube of Q. Alright, and the next part of the question, usually they will ask you to find the number of moles of acid in 1 dm cube of Q, or in the original solution of Q. So for that, this is like a mathematics problem. If we have this number of moles of acid in 25 centimeter cube, what is the number of moles of acid in 1 dm cube? Is to take 1000 over 25 times number of moles of acid. So if you forget this step, chances are you are going to make mistakes here. Next, we'll look at how we can make use of the concepts that we have just learned to solve the questions in this titration. For this titration, we will assume a titer value of 19.20. Now for the first part of the calculations, you are supposed to find the number of moles of sulfamic acid. So that can easily be solved using the 3C approach. The first C is to convert to moles. Over here we are given the concentration of sodium hydroxide. So we also know the volume of sodium hydroxide, which is the titer value in this titration. So with that we can find number of moles of sodium hydroxide, which is equals to concentration times volume, which is 19.2. And that will give us the following number of moles. This is the first C, convert to moles. Now the second C is to compare mole ratio. In this case, the equation is given in the question. The mole ratio between acid and alkali is 1:1. So with that, we know that the number of moles of acid in 25 centimeter cube, remember only 25 centimeter cube of Q was being used in the titration, is actually the same, equals to 0.00384 moles. In the next part, you're required to find the concentration of the acid in the sample of the cleaning product. So in order for us to do that, you need to know how the sample was converted to solution Q. We have seen earlier that there are two things to take note. So the number of moles of acid that we have found in the previous step is only for 25 centimeter cube of Q. So before we can find the concentration of acid in the sample, we must first find the number of moles of acid in your 1 dm cube of Q. And how do we do that? Is number of moles of acid in 1 dm cube of Q is equivalent to this, which is equals to 0.1536 moles. Okay. Next, in order to find the concentration of acid in the sample, we need to realize this, that the sample was actually diluted from 100 centimeter cube to 1000 centimeter cube in order to produce Q. So there are two ways to get the concentration of the sample. I'm going to make use of this, that the number of moles of acid did not change during dilution. Okay, so if there's 0.1536 moles of acid in the final solution of Q, that means that in the 100 centimeter cube of sample, it actually also contained 0.1536 mole. So with that in mind, we can find the concentration of acid, which is just equals to the number of moles divided by the volume. Now the volume would be the volume of the sample, which is 100. Okay. So in this case, it will be 1.54 moles per dm cube. The second way to doing it is this. You can find the concentration of acid in Q first. So the concentration of acid in Q in this case is also 0.1536 because we have this number of moles in 1 dm cube of Q. So to find the concentration of the sample, remember that is the concentration before dilution, we can make use of the equation that we saw earlier. The volume before dilution is 100 centimeter cube times the concentration of acid before dilution is actually equals to the volume after dilution times the concentration of acid after dilution. So that will give us the concentration of acid to be 1.54 mole per dm cube as well. Okay, so there are two methods to getting to the answer, but both methods require you to recognize firstly that the sample was diluted by 10 times to form solution Q, and then with that we can find the and the question actually requires you to find the concentration of your acid in the cleaning product, which is before dilution. Now we'll look at the second example, but before that I just want to point out a typo in the previous slides. The example 1 was actually the 2020 O-level practical paper. This example is the 2021 O-level practical paper. So once again, we need to note the story behind this titration, and as always, we can find the important information about the story in this part. So we learned that solution Q actually contains copper 2 ions. How do we get it? Is by dissolving a screw of this particular mass in nitric acid, and the solution is made up to 1 dm cube. So there was actually 1 dm cube, which is again 1000 centimeter cube of copper 2 ions. All right, and from this 1 dm cube, we actually pipetted out 25 centimeter cube of copper ions for titration. So bear in mind when you see something like this, that when we find number of moles of copper 2 ions using the titration results is only for 25 centimeter cube of solution Q. So for this titration, we will use the titer value of 22 centimeter cube. The first calculation question is a typical one. You're supposed to find number of moles of thiosulfate. So convert to moles, number of moles of thiosulfate is actually equals to concentration times volume. Now in this question, we are given the concentration of thiosulfate to be 0.12, and then the volume of thiosulfate will be your titer value, so 22 over 1000, and that will give us this number of moles of thiosulfate that was being used in this titration. Next, they want you to determine the number of moles of copper 2 ions in 1 dm cube. So they actually skip a step over here. They want you to find the number of moles of copper in 1 dm cube of Q. So how do we go about doing it is this. First, we need to find the number of moles of copper ions that are present in your 25 centimeter cube that you have pipetted out for titration. And how do we do it is to look at the equations. We need to first know what is happening. So after pipetting 25 centimeter cube of copper 2 ions, we have added excess iodide to convert all the copper ions to iodine. And then we titrated this iodine with sodium thiosulfate. Okay? So there are two reactions involved in this titration. Firstly, your copper ions will be converted to iodine, and then your iodine will be reacted with thiosulfate. So in order to find the number of moles of copper ions, we need to compare mole ratio 2 times. Now that we have found number of moles of thiosulfate, we need to actually divide by 2 to find number of moles of iodine. And from the number of moles of iodine, to find number of moles of copper, we need to look at the equation on top. We need to times 2 to find number of moles of copper. So essentially, if you look at this, divide by 2 and times 2, it means that the mole ratio between copper and your sodium thiosulfate is actually 1:1. So the number of moles of copper in 25 centimeter cube of Q is actually the same as the number of moles of sodium thiosulfate. But like I mentioned, in this part, they immediately want you to calculate the number of moles of copper in 1 dm cube of Q. So how do we do it is again by proportion or by mathematics. And that will give us this number of moles, which is 0.106 moles. In the next step, we are supposed to find the mass of copper. So we have already found the number of moles in 1 dm cube. So mass of copper is actually equals to number of moles times your molar mass or your relative atomic mass. In this case, we will take the number of moles that we have found earlier, multiply by 64, and that will give us this. And lastly, we're supposed to calculate the percentage by mass of copper. For that, we need to remember how do we calculate percentage by mass. In this case, that will be the mass of copper divided by the mass of the screw, which is given in the question as 9.5 times 100, and we will get 71.1%. So what we have seen in these two examples is this, that chemical calculations that follow titration, they will definitely invoke the 3C approach. And in order for us to get the final answer, we need to know the story behind the titration, and the story is usually found in the description of solutions P and Q, where they tell you how either solution P or solution Q was actually prepared. So from the story, then you need to take note of things like dilution, and you also need to take note of things where we actually pipetted out a small portion of the entire solution for titration. Now, since we have discussed dilution in this video, I'm going to show how we use it to actually answer the planning question in the 2021 practical paper. So in this planning question, you are given a certain concentration of hydrochloric acid, and then you are going to use that to prepare a fixed volume, a certain volume of hydrochloric acid of a certain concentration. So the very first thing that you need to do is to first convert the concentration of acid that you are given from grams per dm cube to moles per dm cube. And earlier we have already discussed, to convert from grams per dm cube to moles per dm cube, we actually need to divide by the molar mass, and the molar mass of hydrochloric acid is 36.5. So this concentration is actually equivalent to 1 mole per dm cube. Now once you have made the conversion, it becomes very clear that now we need to perform a dilution. Okay, I hope it's also very clear that we need to dilute it by 10 times in order to get 0.1 mole per dm cube of your final solution. So what is left to do is that we need to find out how much of the initial solution to use, and for that we make use of the equation that we have learned in dilution. If you can recall, the concentration before dilution multiplied by the volume before dilution is equals to the concentration after times volume after. So the concentration before dilution is 1 mole per dm cube. The volume is what we need to find. The concentration after dilution is 0.1. The volume that we need is 100 centimeter cube. Now when using this equation, there's no need to convert it to dm cube, because if you do it, the denominators will cancel out. So the volumes over here, you can leave it as centimeter cube. By solving the equation, you will find that the volume of acid that we need to use, that we need to dilute, is actually 10 centimeter cube. So the next thing that we need to learn is how do we perform a dilution in the lab. For that, we need to make use of an apparatus that we do not learn in the O-level syllabus. This piece of apparatus is known as a standard flask or a volumetric flask. Now a standard flask and a volumetric flask is a bit like a pipette. So they come with different volumes. So for example, in the lab, you may find a standard flask that has this volume, 100 centimeter cube. So how do we make use of this flask is that when you add a solution, or if you add a liquid until the bottom of meniscus touches a thin line that's found along the neck of the flask, it means that you've added this volume of liquid or solution. So how do we make use of this to perform a dilution is this, that first we can use a measuring cylinder to measure out 10 centimeter cube of your hydrochloric acid, and then we're going to add this 10 centimeter cube into the volumetric flask, and then we're going to top up with water or deionized water until the total volume reaches that thin line along the neck. That means that we have diluted the 10 centimeter cube of acid all the way until 100 centimeter cube. The standard flask usually comes with a cap as well, so usually we'll cap it and we'll give the flask a few good shakes in order to get a solution of uniform concentration.